Yeah, hello everyone. I'm Vadim Patsev, and I will speak about robotics today. If you was on the last session, last question was about what we will build after we built all our harnesses and so on. And I think I have somehow answer about that. First of all, we have not perfect environment and not perfect solution for my slides. I have a QR code with PDF. You can open this presentation on your phone or your laptop, and it might be better to see slides. So, little about me. I'm Vadim Patsev. I'm team lead at Yandex. Now I'm working on a deep research solution for internal Yandex data. It's about AI, agents, harnesses, and so on. Everyone works on harnesses, I'm too. Before that, I worked on Yandex Mail and Yandex Disk. Here in Armenia and worked on delivery solution for Yandex Delivery, and outside Yandex, interesting projects like autonomous racing and blood analysis, automated blood analysis. So I work on some harnesses and some automation, but my hobby connected with robotics. Today I will speak about some basic things. It's about robotics and how you can start to work with robots today. But tomorrow will be more hardcore speech about delivery robots and some on edge computation, and today some basics how you can start with robotics. My agenda today is the first part. It's about how you can use Python and how you can communicate with robots. Second part, it's about how we can control and what simple instruments do we have in nowadays. Third part, it's about simulation. What if you do not have a robot and hardware, what you can do. Fourth part is about reinforcement learning. It's some common way how robots learn how to do things. And last part, it's about what you can start doing right now. As you noticed, I have some setup on the stage. Little bit about that. I have my laptop. It's a basic MacBook. I have Raspberry Pi sitting here, and it's connected through Wi-Fi. And on USB, I have some hardware. It's a Rich Mini robot. So no cloud, no master node. Everything connected through basic Wi-Fi, and that's it. No complex solution how you can communicate things right now. Under the hood, we have a DDS. It's a data distribution. I forget the word. Data distribution system. I don't remember last S. So it's a protocol above UDP and very reliable reliable standard in industry and Internet of Things. So about my hardware, it's Rich Mini from Poland and Hugging Face. It's 6 degree of freedom steward platform for the head, rotational body with 2 antennas, so motor for every antenna and for body. 9 motors total. It has camera, 4 mics and a speaker, and it's absolutely open source. You have a specification for body, you can 3D print it, and all SDK and all software connected with the robot is also open source. Price $300 for light version. Light version because we have only simple controller for motors inside the body, and we need some brains outside robot. For my case, it's Raspberry Pi 5 connected with the robot. So what we can do this robot with our basic Python. Okay, robot, it's a massively distributed system. Every robot has some servo motors, have some sensors, have controller. If you have number of robots, number of things that we have to control, to communicate, and so on. Different rates, different SDKs, different languages, and we need something to some system to communicate and to connect all of that. So we need some kind of middleware to have communication and we have one with convenient Python API. It's called ROS. We have second version of it, Robotic Operating System. It looks like some microservice architecture. So we have Node as a microservice, some thing which work with one business item, and we have a topic. It's pub/sub publication subscriber pattern with messages, some message broker or event bus. We have a service. It's about synchronized remote procedure calling. And action, it's long-term actions asynchronous with process and which can be canceled. Parameter, it's not about a parameter, it's some runtime config which we can edit on the runtime, but it's not very important. So yes, and we have DDS under the hood that as a transport that connect everything together. So ROS have a C core, C writing on core. It's a robotic control library, and the thin language libraries for right now it's 2 languages. It's C++ and the Python. So 2 official clients and the Python and one of them. So everything which you can use in C++, you also can use in Python. Nodes, executors, QNS, quality of service, and lifecycle. And you know, if you know Python, you can communicate with robots on the stage. So first demo. It's about topic. Topic, it's some event bus with stream of messages. And everyone can publish and everyone can subscribe. And you can read something about state of the robot. Our robot constantly push some state of the motors and head position and so on. So some basic idea how to write Python code on ROS. We have a node, we make class listener, we init something in terms of ROS, we create subscription. Interesting thing about join state, it's object, typed object about state of the robot or joins of robot. And we can create subscription. And in my demo, I simply log something on a console. So some initialization and spin it's some loop for that listener. So let's try to do something. Yeah. And we have a lot of messages. Our robot push messages to a network. And I have two nodes, one on my laptop and the one in Raspberry Pi. Robot pushed some state of the robot, and I subscribed on my laptop. So I can know something about this robot. So, yeah. Oh. What's going on? Yeah, okay. So, and right now I would like to do actually something to control the robot. First of all, we have a service, predefined services in the robot. It's some kind, it's synchronous remote procedure call, one-shot command with some answer. In this robot, we have some useful wake up, sleep, and another motor, enable motors. And I would like to wake up this Rich Mini. Also, some basic idea how to do that. We create node, we create client, we call trigger, and we print some response of this action or the service. Oh. Lost connects to the server. Oh, what's going on? Sorry. I lost connection. Okay. Not stable Wi-Fi here. I think.
I have a hotspot in case you need it. Oh my God. Is it friendly?
I guess so. Yeah. Okay. We have success. We have message. I don't know. Yeah. We have success true and message that robot waked up. Okay. Yeah, and the next one, I want some moves, so I want more control. Okay. Yeah, and topics works in both way. We can read messages and we can send messages. So we can stream some message to make some movements of the robot. Basic idea, we have a head pose and we make some pose stamped, some position of the head, some properties of this position, and we push it to the robot. We make some one pose to rotate 60 degrees, or we can push every move, every degree to the robot to have a more control and make some changes in runtime. So we can start to rotate clockwise and make another decision and go back and so on. So it's to approach to make some things. So let's try to do that. Oh. Wake up. So we can push some messages to the robot and make some movements of head. Okay, so we have some sensors inside this robot camera, and it's also the message type, so it's objects, and we have we saw John state, post stamped, and right now we can work with compressed image. And you can subscribe for this message from laptop or some another device to make some decisions about what we can see on the images. So make some computer vision and so on with something with GPU, maybe in cloud, and so on. So how in my setup camera works. We have eye camera in the robot connected through USB to Raspberry Pi. So we have some stream video to the which we pre-process on the Pi. I have some pre-processing to make compressed video from the stream. I have a topic with compressed image with 10 frames per second, and I have subscriber on the laptop with some OpenCV wrapper to show the image, show the picture. It's just a message, so pops up also works, and you can make some pre-processing and whatever you want. Compressed images for this Wi-Fi, because we have some problems with that. So yeah, basic idea of subscription. We have a ROS node. We create subscription for compressed images and some method for processing of the result of the message from the topic. Let's try to do. Okay. Say hi. So we worked with camera on my laptop. My laptop don't know anything about what's going on with camera inside the hardware, and I work only with messages of compressed messages. Yeah, I will close it. Yeah, and what? Oh, cool. What about some complex movement? We have a body which can be rotate, which can be rotated. We have a connected head also can rotate. And what if I need some complex move when I want to have camera steady and rotate body and head simultaneously. We have some additional library for that, because body and head have frame of the coordinates, and we need to sync them, angles and speed, and we need something which can be useful for that kind of calculation. So we have a TF2. It's a basic idea and code some more complex, but we have some library which can be useful for that kind of calculation. Yes, we have a basic link. It's stand of the robot. Body can rotate it and head rotated, and we need keep angle of the camera relatively to base link, and we need some calculation in between. So let's try to do that. We have a camera angle of the camera in a frame of the world, so or base of the robot, and we have coordinates of the body and the head in the messages. So it's not perfect in terms of value of the angles, but you will see that you can see that we have a 30 degrees of the body and of the head. Okay, so some complex movement, and we can control it with some basic programming skills with the Python. And we have an action. Action, it's the last part of the instruments that we have to communicate with in the robot world. It's long-running job with a goal and feedback stream how we proceed to the goal, and we can cancel it. We can cancel it. So yeah, how we can work with the actions? We create a client. We set a goal, some name, and we send this goal to the topics to run some long-term action on the hardware. Let's do some dance. We have a progress here. Yeah, and action, it's a good way how we can control where we do calculation, because one way we push some low-level messages about every move of the robot, every motor and every joint of the robot. And another approach, when we make decision on some brain of the robot in Raspberry Pi, and make some goal which we can call from some master node or something. So it's balance between where we do calculation on the hardware, or maybe in the cloud, or where we have more resources. Yes, and in this stuff I move everything to the Pi, because we do not have stable connection for that. Another building blocks which we have in ROS in the robotic operating system it's enough to move it RDF, Gazebo, SV Bridge, and TF2, which I talk about. NumFOCUS, it's about navigation, so drive from point A to point B. And the interesting thing that in terms of domain, it makes in terms of pose. So in this robot, we have pose of the head, and in robot with some wheels, we can make the pose of point B. So it's some kind of same domain with same actions, and we can do programs with the same ideas. Move it. It's about how we. It's about kinematic, direct and inverse kinematic. When we have connected joints and we need and some actuator like grab in robot arm, and we need to move this actuator to some point in space, and we need to calculate which angles do we need in every joint. So it's about make this calculation, how to make this kinematic. And also it library has a collision thing, so we on a scene we can have some what's going on? Okay. So and we can work with collisions. CV Bridge, it's a library for working with images, and I have some basic demo. But CV Bridge can be connected to OpenCV and make some more complex stuff. And interesting things, it's universal robot definition format. It's some XML format which define physics and some shape of the robot. And if manufacturer of the robot provides this kind of thing, and some popular platforms do it, we can use this format for some visualization, and more interesting, we can use it in simulation. So we have format, and we can put our robot in simulation with help with one file and one format. What do we have for simulation? Gazebo, it's a ROS native simulator with physics and with good support of the ROS. Mujoko, it's more about reinforcement learning and more fast and but without complex physics. And the most powerful NVIDIA SAC lab, thousands of robots, very complex scenes, and with purpose of automation of huge warehouses with thousands of robots. But you need to have a lot of GPUs for that. So at least 24 or 32 gigabytes of video memory in one GPU, and for one robot. And you need a lot of computational power to work with that, but very powerful and very complex physics because of NVIDIA and gaming experience, but need a lot of resources. Gazebo, it's the most ROS native way to work with simulator. You run a world, you load your robot with RDF format, and you have a ROS GZ bridge to have some topics about what's going on in your world and with your robot, and you work with the topics and nodes in the same way as you work with your hardware robot. But in the purpose of this demo, I chose Magico because I do not have a lot of resources here and I need some basic visualization. So let's make dance in simulator. And we do not have nothing.
Maybe Wi-Fi problem.
Maybe.
Can be because of the noise.
Okay, I don't know. Okay. You can try it after my speech with my code. Yeah. So, and how robots can learn something in real world. I guess everyone knows something about reinforcement learning. But in the basic, we have some observation of some environment. In my case, it's joints and pixels from the camera. We have a policy, some network which can make some decisions. We have action, rotate the motors of or make something in this environment. And we change the environment. We make some observation, and we have reward how we close to our aim. We have no labeled data, only some function of the reward and observation of the environment. So we may have some millions of simulation of this policy, and our network learns how to do things more efficient in terms of reward. So basic stuff, and we have a lot experience with reinforcement learning. And now in the real world, robots with the help of reinforcement learning may do some complex stuff like parcel sourcing, picking up and storing. We have a humanoid who can run and makes acrobatic things, and we have some sidewalk delivery with our cute rovers. So everything of that making with the reinforcement learning, and now it's basic way how to robots can learn new things. Reinforcement learning have a good instruments in Python, and I guess we know something about gymnasium. It's basic things, how to do environment and some reinforcement learning. Basic idea, very few strings of the code in Python, and huge world how you can implement something interesting in a simulation with this approach. And interesting thing that with URDF simulation and approach, when you can use ROS specific topics and nodes in the simulation, it's way then you can do your policy in the simulation and deploy it in hardware and use the same code with the same nodes and same topics in a real robot. Yes, you have to do some domain randomization in environment because real world more complex than simulation, but it's a working way how you do basic stuff with some basic moves and decisions in the simulator, and take this code, deploy to the hardware, and make some tuning, only tuning do on the expensive and slow hardware in the real world. So what you can do right away? Python is enough to work with robots. You have robotic operating system as a playground with a lot of libraries which can use right now. And robots, it's not so expensive. Rich Mini open sourced and $300, and it can be shipped in Armenia. Free country, I love it. And yeah, you can install ROS through Conda if you work with some data stuff. Conda, I think you know how to do that. In my repository, you can find some examples how to work with Vichy, and I also have a simulator and the file for Richie, so you can do some things in simulation with this code without the hardware. So your Python today have you can talk with a robot today, and yes, last things, but my robot already sleeps. Yeah.
Maybe it can wake up and then sleep.
Okay. Okay.
You don't have a connection. No, I think.
Maybe let's try it.
Doesn't work, but the real robot works.
So, well,
Yeah.
robot is better than simulation.
So thank you.
Amazing, thank you. Do we have any questions? Lots of questions. Do we have any microphones?
Yes, of course.
Thanks for presentation. Actually, it's truly amazing, especially to work with robots. It's always exciting. I'm not sure about the role of the Raspberry Pi. Am I right in thinking that all these sensors connect to the Raspberry Pi, right? And then sharing data using
Yeah, yeah.
message broker here.
Yeah.
Okay.
We have not expensive controller inside the robot, and there are streams of the sensors from the robot to the Raspberry Pi through USB.
Mm-hmm.
And yeah, has some pre-processing of the streams for sensors you have to do in the brain in the Raspberry Pi.
And commands you push directly to message broker into Raspberry Pi. And
I have two. I have two nodes. One ROS node in the Raspberry Pi and node in my laptop, and I communicate only between the ROS nodes in my demo.
Mm-hmm.
So I have communication within the ROS and some SDK and preprocessing of streams in the Raspberry Pi, which have bridge from SDK to ROS.
Mm-hmm.
in the Raspberry Pi. So my laptop does not anything about rich mini hardware and streams within the robot, but only knows about ROS nodes, topics, and the messages from the ROS.
Mm-hmm. And Raspberry Pi here connected with your laptop using Wi-Fi, right?
Yes, yes.
Okay, cool. And about the message broker, right? Is it kind of, Kafka or?
It's DDS.
Mm-hmm.
It's a protocol within the ROS, and you do not have to think about which message broker do we have. DDS handle it in the ROS.
In this case, I just need specific library to process
ROS.
it. Okay,
ROS.
Cool. And is it compatible only with Raspberry Pi, right?
No, Raspberry Pi is basic Ubuntu. You can use everything which can run some Linux stuff, and when you can set up the ROS. It's Ubuntu, Linux, and
Okay, cool. Thank you. Thank you.
There we have a question. You have questions also.
Oh, thank you, Vadim, for the presentation. I had a quick question about
Sorry, I didn't hear.
I have a quick question about the communication between the ROS nodes. So is there any authentication mechanism, or if I connect to the same Wi-Fi and run a ROS node, I can technically send the commands or read the sensor data from the RPI too?
Basically, out of the box, you need to set up the same domain of the ROS node to handle the visibility of the ROS in your network, and that's it. If you see another ROS node, you can communicate with it. Also, DDS has a very complex system of quality of service, and it's a lot of variability how you can handle the messages. Do you need acknowledgement, and how you prove the receiving of the message, and so on. Very complex and reliable standard which used in heavy production. And DDS have a lot of instruments for for messages and how to handle them.
Thank you very much for interesting presentation. Robots are evolving. Some people are afraid of it. I'm not. Anyway, so the question is, does ROS 2 follows 3 laws of robotics by Isaac Asimov?
I don't know how to answer. It's not connected things. Okay, let me put it this way. Does our AI harnesses follow the three laws? I guess not. And it's comparable things. ROS is harness for robotics and how we communicate and control things in robotic world, and it's somehow like harnesses in AI world.
Thank you, first of all. I'm going to go a little bit deep near the hardware. So the messages, if I'm not mistaken, the messages are being interpreted to drivers by the Raspberry Pi. Am I right?
Messages from my laptop. Some control messages, yes, interpreted being interpreted by Raspberry Pi, and through the bridge make some signals to SDK of the Rich Mini in Raspberry Pi.
Okay, and do you have any idea about the software inside the robot, or is there any open source package that I can use to build my own hardware for the robot?
Yeah, Rich Mini, it's open sourced. Every software which used in this robot you can take and make your own robot. Also, they have a schematic for physical body, so you can print out on 3D some new kind of body or head for this. And specification of the motors also available, so you can buy some hardware, some motors, some antennas and controller, and make your own Richie with your custom body, with some additional maybe hands and so on. So this project is open sourced, but in the real world, robots are proprietary, expensive, and open sourced. It's not. It's more for fun and for education, for some research, but for production, for business, it's like a proprietary platform which you have to buy and have to spend some money for that.
Thank you.
Just a few questions.
Thank you for your talk. It was amazing. I have a question about the SDK and capabilities. So you told that you, like, for dance or something else, you pre-created sequence to prevent the Wi-Fi jitter and something else. So my question is, do these actions have some condition or business logic? For example, I have a camera. If on the right I see green, go forward. If I see red, don't go. And if not, do this, like, if I want to make some conditional logic, do I need to do the round trip and resolve this on my node, or the robot can do it by itself?
It depends what resources do you have in your brain of the robot or some another source of calculation. So it's a question about where I can make decisions about hardware and what I do next. It's two policies of that. You can do everything inside the robot, and tomorrow speech will be about that, how you can make navigation robot with every decision inside it. And another approach, you have very thin hardware and very thin brain in your robot, Raspberry Pi 5, and all computation you do in your laptop or in the cloud with some GPUs and so on. So you can make actions and make some small signals from the outside world, or you can push a lot of messages with moving of every motor in your hardware to make control signals to the hardware.
Okay. I think you mentioned this, how it's called. The dance was a service, it's an action, right? So action is a ROS term.
Yeah.
So the question is, in this ROS term, do you have place where you can do actually decisions?
You can do both way.
Yeah, so it works. So the functionality is supported
Yeah.
inside ROS.
You can push a lot of messages to the topic to make every move of the robot. Or you can push one action with one goal, and
Take new action.
yes, of
My
course.
own,
Yes.
with some business to conditional
Yes.
logic.
Yes.
Yeah.
You may have an action with some business logic inside your robot and push this action from outside world to start them.
Yeah. I guess if I understand, you can just push a logic to server or client side, depending on the resource availability. Yeah. So my question is like related, but it's about, you mentioned there's like two SDKs. One is C++ and Python, right?
Two clients for the ROS.
Yes, for the ROS one. Yeah. Is there any other languages, and is it the parity the same between C++ and Python?
There is parity between C++ and Python, and I guess right now we don't have another implementation of the ROS library, official one. I think I saw something with Go, but it's not official. I think ROS and Go, it's obvious non-official clients for the ROS. But with agents, it's doesn't really matter which language do you use. So I think my next project will be in C++ because you do not have to read the code anymore. So.
Thank you very much. It was amazing.